Yes, Deepan, kindly continue. Recording started.
Okay, ma'am. Thank you. Yes. Yeah. So this particular session, right? So it's like more of an hands-on method. So there are no fancy slides to accommodate that. We just have only one information which you have to understand. But before we go into this RAG and other stuffs, we'll try to understand like how to what are LLMs. So basically, we did know like what are transformers and what are the capabilities. And I know that we all are using LLMs, different GPT models, to get things done, right? So that's what we're going to do right now. But instead of us going on, and looking for different components and different LLMs, how do we target the right LLMs for the right task? And how do I create my own personalized response for a given document? Let's say if I have a document with me, how can I, make sure the response which is created by the LLM is in aligned towards the document which I have. So this would come in handy when we are creating our own personalized chatbots. Let's say if it is VIT, right? So maybe we can have all the information about VIT in a particular document, and every time you ask a question, the model can go into the document, search for it, and give you the respected answers. That would be really a useful thing. Not just for this, there are many other places, especially in terms of corporate scenarios. This will be like very much useful. So if at all we talk about releases, documents, or software requirement documents where all the information about a particular software will be there in a document. How do we use that document, extract informations? How do we create case studies? How do we create test cases with that? How do we create programs with that? So all these things comes under this particular session. So we'll just see like how each and every component can be done. So first thing is like, you can achieve this approach using two methods. One is using an online LLM server where you can connect to a different servers like OpenAI, Gemini, Grok, or any different APIs, considering you have a premium version of that. But if you don't have it, it's fine. We can just directly go to this program called yeah. So just go to this same handle, Deepan Raj here. But this time go to the repository named Deep Learning. Okay. And you should see a program called openrouter.ipynb. Okay. Just open this particular program, and I'll just pause for a minute so that everyone will open this program and keep it ready. Okay. So I believe like everyone has opened this particular program. So this program has multiple things inside it. So this is a way you can where you can connect to an online server and get different LLMs for usage. And again, as I told you, if at all you have OpenAI keys or Gemini or any other premium LLM versions APIs for free, you can use that as well. But for now, what we're going to do is we are going to use this open router website. You can just, once you open this, you should see this website named Open Router. Just open that particular website, go to this website, open it. You can sign in towards it. Okay, so once you sign in, this basically this open router contains almost like all the LLMs which is there in the market, and you can see like 8.4 trillion monthly tokens have been utilized within this particular, and they have 400 plus models and 2.5 million users globally. So it's a very good single place to connect different, because if you take OpenAI, you can just if you buy OpenAI subscription, you can only use OpenAI. But what they do is they tend to give different LLMs, let's say from Anthropic, from OpenAI, from Google. They kind of give you any different you know options for you to connect with. So but what you're going to do is we're just going to first create a key, okay, so that we can use that key for our uh, further development. So what we are going to do is, let me just delete all these keys so that I'll just show it to you one by one. Right. The first thing is, like, you just have to log in to this website. I'll just show you the website again. It's openrouter.ai. Just open that and go to the profile section and just click keys. And you can create an API key here. Just let's say I'll just keep it as test and just click create. Once you click this create, you should be getting this key value. Just copy this key and paste it here. Okay, just paste it here. Now that the key is ready, and next thing is, like, once the key is ready, I can browse for different models. Okay, so I'll just close this out. You see this models, right? If I click this models, you can see many different models available here. But the only thing is, like, the thing is, you cannot use this model for free. You have to pay for it. But the beauty is, like, you have some freewares given by them. Let's say you can see Gemini 2.5 Flash image preview for free. Whenever a new model or something comes into play, this open router give you a free version where that you can use that for free. Okay, you can see, like, you can use this image preview. Basically, it's a state-of-the-art image generation model with context understanding. It's capable of image generation, edits, and multi-turn conversations. That's one thing which you can go with. Or recently, OpenAI launched, open source models, right? This OpenAI GPT OS just 20B. It's also available for free. I'm just going to copy this. Okay, let's copy this OpenAI model and paste it here, so that we'll be using this OpenAI GPT model for our for our conversations. So the first thing is, like, just make sure you install these packages. Okay, just install these packages one by one, and also clone this repository so that we use it for loading a document and using a rack pipeline on top of that. So that's what we're going to do right now. But yeah, so I'll just give you some more time to just absorb the facts. Just open this site called openrouter.ai, sign up towards it, go to the keys, create a key, copy that key and paste it here, and go to the model section and search for free models. You can use any free models. Okay, wherever you see this free option, you can use those free models. Okay, not every model is for free. Let's see, you see this Z.ai, JLM 4.5, and then we should be having a Quen model, Quen coder. You can see this Quen coder is a very big model. Okay, you can see it's a 480 billion parameter model, and they have given it for free. So you can use it on your wish. And you can see here, right, basically it's like top 2 in terms of programming, top 7 in terms of science, and top 10 in terms of technology. So which means it's like the best model which you can get to do. So yes, you can choose any model, but I'm just sticking with this GPT OSS. But you can copy any model. Just copy this and paste it on the model section and be done with it. Okay. So by the time all the installations are done, I hope every installation is done successfully, right? So yeah, once every installation is done, we'll just get things started. So basically, this is the a skeleton structure for any LLM communication. Okay, so if you want to load an LLM, which is an online or offline or any place, this would be the program which you're going to use. Okay, the first thing is, like, we are going to use LangChain. So what is LangChain? LangChain is a library that helps in connecting different LLMs, not just LLMs, different vector DBs, different embedding spaces. You can do agentic orchestration. You can do any such developments with this particular LangChain. And for now, we are going to use a chat method to load our own our different LLM, and we are going to feed some input. That's where this human message and chat OpenAI comes into play. So these are the two important imports which are done. The first thing is like I'm just gonna like give this open uh, API key and API base. If you see like this is stated as OpenAI because back in that particular time when LangChain was created, we only had OpenAI. There were no other LLMs which was available back in the market in 2019, and that's the reason why still they are using it as OpenAI. But don't mind, you just have to give an API key and an API base. So this is the base where we are going to create post the methods and get the completions. Okay. So do in this base, if we post a method, a text or a data, you will get the completions out of it. Okay. So I'm just creating an environment variable for these two. And then this is where I initialize the LLM. So what I do is I call the function chat OpenAI, given the model, give some temperature. So temperature is basically a creativity. Okay. More the temperature, more the creativity. And sometimes if you keep a temperature to be one, it becomes hallucinating as well. Because as we know that GPT models has a tendency to hallucinate, it will unnecessarily give you some wrongful answers that can be a problem. So make sure you have a decent temperature value here. I just stick with zero point 0.7 and then I give the API base and the API key and give a request timer so that the connection is not established within 60 seconds. This will come out. Okay, once the LLM is connected, all I have to do is, yeah, I'm just creating a simple while loop so that I can communicate with it. So I just create a simple while loop query where, I'm going to get the input from my text command. So I just use the input to get the text. And if the text contain exit query or by, I'll just break it, or else I'll just push it inside this query. So inside this human message in the content section, I'm going to give this input whatever which I given, and that is given to the LLM block, and that LLM block will be given here, and that basically gives me the response. And the response dot content is printed over here. Let's see the output for it. Okay, let me just run this. Okay, let's say let me just ping hi. You see, like, hello, how can I help you? Teach me how 1 + 1 is equal to 2. So as a default, like, it will have some limited thing. So you don't get to stream the output. You just print it everything together. You see the output here, right? So the assistant, why does 1 + 1 is equal to, below is a simple hands-on explanation. So it's like, first thing is everyday intuition, a bit of a formal math, and then some quick recap. So whatever LLM which you usually get, right, you can also do the same here. Got the idea, right? So basically, instead of you going into ChatGPT and typing the output, you can do this here. The advantage is you get it in terms of a string. You are getting in terms of a variable where you can do a lot of adaptations, right? Instead, imagine you have this power of LLM, you can attach it to any different applications which you have. All you have to do is just connect to this LLM provider, and the job is done. You can get any sort of outputs, represented, created, and and can be beautifully made with this approach. So this is one ideology behind connecting an LLM and communicating with it. Hope this is clear. So any doubts or clarifications? You can. I hope everyone can able to run this particular block by changing the API key and the model name. You don't have to change any other things, but just make sure you are doing the correct thing. So I'll just pause for a minute to get queries or clarification like on how to run it. Then we can continue for the next block. All right. So which means like everyone can able to connect the same. So this is an online method of doing things, right? So where you can give an API key and a base value, and then give some free models if you find, and be done with it, and you can communicate with an LLM and get some answers. So what else you can do? You can assign roles, you can give some interesting informations, like in the query you can append some more information, like you are an assistant, keep things to a certain value. So likewise you can create system prompts, you can do a lot of stuffs within it, like how you use a chat GPT. But the only thing like here is you have it in the backend part. So you can do any sort of wonders with this, you can get any sort of outputs, and be done with it. So that's how this open router can be very useful. If at all you don't have any premium versions, this would be the deal too. Now how about we do the same thing in our local machine? Okay, instead of using a collab, can I use my local machine to do? That's what we're going to see right now. So in order to do that, let me just open. So these programs are available in my GitHub repository. If you go to this rack folder, same, I'll just show you the path for it. You see here, like all you have to do is just go to this GitHub repository named Deepan Raj M, in which go for the repository. There are like multiple repositories which will be there. Just open this deep learning repository, click onto that, and you should be seeing a lot of programs inside it. Just go to the rack part, and you should basically see like all the programs which is available. So all you have to do is, Mhm. Yeah, so all you have to do is just open this rack part or any of such program. I'll just show you like which program to open so that we can use it directly here. So let's open this LLM, open router itself, the same program. All I have to do is just, uh, let it open. Yeah. Here you have to install all the Python packages and everything. Okay, so once that is done, I can just simply connect to my package, and all I have to do is change with this particular API key, right? Into this API key, and change the model name. Yeah, that's it. I can just simply run the same program, and that's it. Job done. But again, when running it locally or in Colab, kind of relies onto this open router, because without this open router, we cannot. Okay, yeah, you see this option here. So if I just type hi, you get the output. So very similar, like you get the output printed here, just like how we did in the Colab. The only thing is like we are using a local instance. Okay, plus 1.1 plus 2.6, something like that. If I ask a question like that, it goes to the LLM and gives me the output, something like this. So it's very much feasible and easy to do. I'm just giving exit to stop it. So if at all I want to use my local model, okay, if I want to use a local model to do stuffs, all I have to do is use this line. Okay, I'll just show you like where this can be popped out. Just give me a second. So instead of this chat OpenAI, I'm just using the Open API base as this particular local host, and my model can be anything. Let's say if I just comment this out, even this. Okay. Now I have an entirely local host running inside it. So all I have to do is, just download this particular software called LM Studio. Okay. So go to the LM Studio and then download the software. This software is a streaming software where you can download LLMs within your local system. So if you have it in your local system, right, so you have even more better understanding or you can do a lot of stuff within your local environment. You don't have to rely on any other online forums, online servers, and every data will be hidden in your system. A lot of privacy will be there, and a lot of other, other activities can also be done. So the only thing is like you have to download this and install it. And once you install it, the exe will look something like this. I'll just open it. But again, heads up is like, your laptop should be little faster for this, because we're going to load some, some models, some LLMs in your system, and we're going to get the response from that. So, just make sure you have a better system before download and do the stuffs. So what you have to do here is, you have multiple options like this. Go to the discover option, search for a model. Okay, so whichever model you feel like the model can be downloaded. So let's say if I click onto this model, it shows that it is likely too large, because this is a 70B model that requires how much size? Just show you the size of it. It requires 37 GB of GPU size. That's not even possible from my side. So all you have to do is just go for small size models, and based on your compute, right, based on your system requirement, if you have some GPU or anything like that, yes, you can download. So in this case, you see, right, I have a model that has the stick symbol. Because the size is small, I can load it easily in my system. So basically my system has a 4 GB GPU. So I can run till 2.5 to 2 GB, but beyond that it's going to be a little difficult. So what I did is like I just downloaded this Quen model, Quen 3 1.7 and zero point 0.6 model, where I was able to load till 2.7 GB. Size also can be done. So I kind of loaded these models with me. So I have this Llama 3.2 1B instruct, I have a Quen 3 model, I have a Gemma model, and I have a Phi 3 model. So likewise, I have downloaded many models, and you can see, right? So this hammer symbol represents it's an agentic model. It can give you some agentic output, and it has some thinking capabilities inside it. So that's the advantage of the Quen model. You can also go and discover any models and download it, so that you can host this model in your system and you can start communicating with it. Okay, that's the advantage of using this LM Studio. And basically, LM Studio works for almost all the systems. But if you have a Mac laptop and if you have an uh, processor, Intel processor in it, then yes, you can't install this particular software in an Intel architecture based MacBook. For other remaining MacBooks, you can download and install it. Okay. So all you do is just click on to a model, go to the discover option, click on to a model and just download it. Let's say like if I go for this, all I have to do is just make sure if I can able to at least load it. Sometimes it will show something like this. Partial offload is possible. So what is this partial offload? So partial offload is something like it will make use of both the GPU and CPU, because as I told you, I have a 4 GB GPU, which means that I can load till 5 GB, maximum 6 GB I can load, because remaining 2 GB of the contents will be loaded in my CPU. Okay, I have an i7 processor, so it is capable enough to do that. So that's why I can able to load up to 9B models, because again, bigger the size of the model, more processing which you can do, it can give you better responses. That's one another important thing which you have to keep in mind. Okay, so now let's load a model here. Let me just load the Quen model. Okay, I'm just doing it. Just loading here. And once it is loaded, you can use this post method. You can see all the methods available here. So we can use this post method to post the questions and get the completions out. Okay. So that's what we're going to do. So yeah, once it is loaded, you can toggle this status option. Okay. This is where you deploy this LLM in your local machine as a local host, and you can load this LLM. So you just run it. And once you run it, you can see the developer logs here, right? So the system is started. You have the completions method and everything ready to listen. All you have to do is just post the method and get the completions out and just adopt it. And you can see this is reachable at this particular server location. And if I go to the program, that's what I've done. So you can see I've just taken the same IP address and followed by V1. And the API base is not required here, because API base is the same. because it's a local host. I don't require that. I just have to need the IP address. Only the API base is required. I don't want the API key. Sorry, API base alone is required. API key is not required at all. Okay, that's it. Plain and simple. So all I have to do is just again, if I run this, now this will again ask me a question. Now if I say hi, this goes to my, you see, right? So it goes to my model LM Studio and gets me some output. So you can see the output is generated here. You can see the output here also, and the same output will be populated here. So, and the beauty of this Quen model is like it has this thinking capability. It says like the users just say hi. I just need to respond in friendly and helpful way. Let me check if there's any specific they might want. So they don't ask for anything else. My response should be simple and welcoming. Maybe start with a greeting like hello or hi to acknowledge the message, then add something like how can I assist, something like that. It was just thinking on it, and then you got the output. Hello, how can I assist you? This is the output which we have got, but you also have this thinking output also generated out. But if you see that, so I just ask like teach me 1 plus 1 equals to 2. We ask the same question just like how we ask for GPT. This will give you an altogether different output because it's a very, very small model. It's a 0.6 billion parameter model. Okay. Now, again, it goes down there, it generates the response, it gets you the output in some time, but it will take some time to, give you the output. You see it. So the output is generated here already. Thinking output is generated. It got some output as well, but for some reason it's not printing it down here. That's kind of strange. Huh. You see it? So the output is generated here. So assistant is thinking, and then finally, okay, I'll just have to show it in a different text editor to show you the full output. You see it? So this is the output they have given. The equation 1 plus 1 is based on regular arithmetic where it follows an alternative interpreting it is a riddle or a play on words. And so it could be 1 plus 1 equals 2 because of the word play. Most of the manual exercises 1 plus 1 equal based on arithmetic. So this is the output which you got. And it is thinking for a long time and gave me things. So that's why this Quen model is a very good model because it can think. And this is more of an explainable AI as well because this gives you what it is thinking, and it will help you to understand like how the model behaves. Based on that, you can structurize the output or structurize the prompt accordingly. If you can structure the prompt accordingly by understanding its mind voice, you can leverage the rightful output for the same. That's the advantage of using this kind of thinking model. And yes, it is also equipped with all this MCPs and agentic protocols inside it. It can give you a whole lot of better output for the same. So that's how you can use the same program and connect to an OpenAI based online server or even a local server that is equipped with this model. Okay, so let me just stop this. I'm just going to stop this also, like, and let me just eject this so that it won't consume my GPU. But you got the point, right? So all I have to do is just use the same thing, but instead of API key, all I have to do is given the model name. Again, model name is also not much important here because we just loaded one model. But if we choose a different model, that will try to see if at all we have that model inside it, and it will try to load that model. If not, it'll just stick with whatever model we have, and then it gives answer from that model. Okay, and we don't require API key because it's a local host. You just have to give the API base alone. Once the API base is given, and that's it, job done. Yes, ma'am. So, any questions?
Yeah, participants. Yeah, so there was one person, Saranya ma'am. Saranya ma'am, you raised your hand. Do you have any query? So can you hear her?
No, ma'am, I can't hear.
Okay. Participants, if you have any queries, you can raise your hand, please.
All right. So hope you got some basic idea about LangChain and how to do a basic communication with LLM. This is how you can do it. Either you can use a local host or use open router or any open AI base to chat with the LLM and get some output done. But that's not the end. As I told you, we'll try to understand like how to do a RAG pipeline. Now, what is this RAG pipeline which you're talking about? Now, imagine, just open the presentation. Sorry. Yeah. So imagine you have some document with you and you need to just give me a second. Yeah. So imagine you have a document with you and you have to, get some output from that particular standpoint, and make sure the response is much more personalized to your question. Because sometimes you ask about tax and all it gives you some generic opinion on tax. But what if you have some document of tax and you ask it to, generate outputs in that particular fashion? That would be much more easier and exciting, right? So that's what drag pipeline is all about. Okay, now let's see how this pipeline works. So basically what we do is we just take all the knowledge base. So this particular image is taken from NVIDIA's portal. So they also create a rack pipeline which works for their enterprise edition. So basically what the deal here is, we will take the input data. Let's say we have some PDFs, we have some CSV files, we have some documents with us, and we have to load that particular document and answer some questions for it. So in order to do that, first we extract the contents from the data from the documents, and then we will pre-process it. Now, what is this pre-processing? What does it do? So let me just open a program, sorry, open a PDF so that you know what it is. So this is the PDF which we are going to load and get some RAG out of it. So this is a basic home remedies PDF. It has some common home remedies for cold, flu, cough, headache, joint pain, insomnia, something like that, and some healthy lifestyle, something like that. So if I ask about sleep hygiene, it should give me some information from this data. Okay, something like that. So this is the data here. So this pre-processing is something like, if I go back to the architecture, you can very well see that the usage of LLM is only at this section. Reminding is just a very simple, software, and you pre-process, you embed it, you store in a vector DB. Everything is kind of not revolving around LLM. The only LLM part which you see here is the last part of it. So basically, we kind of present this data in a much more beautiful way so that the LLM can give you some output. Let's say, if I ask a question, how to, how to resolve cough. Now, what I have to do is I have to copy this data, give it as a comprehension, copy this data, give it as a comprehension, and post that question and ask my LLM to answer to the given question based on this above context alone. Instead of me giving the entire document, because that's going to be huge, and sometimes you'll have a very big document. Instead of me doing that, what if I just take the important data alone, take the most important data alone, and then paste that information. Let's say based on the query, I'll just look for the similarity of it and then look for the important data and fetch it. Now, how do I fetch this data? That's where the pre-processing happens. So basically, we will convert the entire data into chunks. Okay, chunks of data. For example, this can be one chunk, this can be another chunk, this can be another chunk. Likewise, for every piece of informations, we will convert every sections into chunks so that when I ask a question, relevant chunks will be retrieved and will be given as a context to the model. Okay, so if we can do that, the model can give the right output, because LLM is not fine-tuned or not being trained down here. We're just presenting the data in a much more consumable way by the LLM, by taking down the query and retrieving the right possible data for it. That's where the RAG pipeline shines. So if you see here, we pre-process it, we we chunk the data into several pieces of informations, and then we push it into an embedding model so that it will be converted into a higher dimensional space. Because if you have it as a regular document, and it's like a similar to your Google search where you ask a question, if those words are available in the sentence, it will give you an answer. But sometimes representing onto a higher dimensional space will have a much more semantic meaning, stating that you can have a better way of finding the right right contents for your query. That's why we do this embedding, and then we store it in this vector DB. Now, this vector DB is again, it's like a regular DB. Okay, there's no fancy things behind it. It's a very regular DB, but only thing is that it stores informations in form of a vector data. Okay, because it's a 64-bit vector data. Likewise, you can store different datas into the vector DB, so that whenever you ask a question, the question will be converted into embeddings again. Now this query embeddings and the retrieval will go here, and will try to get this embeddings and try to get the relevant blocks from it. Okay, that's how this is done. So basically, whatever question you ask, that will also be converted embedding. This embeddings will be matched against the entire documents. See, like which chunk is very much close by, and then whatever is there, you try to get the output and try to push it to the LLM. So now the LLM will have something like this. Let's say that context. That's the one which is retrieved from the document chunks. You'll have the query and you will have the answer. Now the answer will be given empty, so that this will be filled by the LLM. So LLM has no fine tuning done here. All it does here is it gets the context.
Yeah, please proceed.
Yeah, so we have the context for the given question, and this works as a comprehension right now. So you'll have it as a comprehension, and the comprehension works really good for the LLM because you're just asking a question and trying to get the answer on the context and getting the answer. That's it. So the answer will be provided to you. So that's how the RAG pipeline is created. Okay, it's called retrieval augmented generation. Basically, you are retrieving for a given query, you augment it onto an LLM by like presenting as a new information, and you generate it. That's how RAG pipeline is generated and created. So simply to summarize this, if you have a lot of data, you just ingest the data, and then you extract the components from the data. You pre-process it by converting into chunks. Okay, again, this chunk can be done manually also, and it can be automated by semantic chunking and different methods which is there, so that you get the right chunks provided for it. So once the chunks are created, you just push it to a vector DB. Make sure, sorry, once the chunks are created, you convert into embedding value, so that every data is converted into vector values, basically your embedding vectors, and those vectors will be stored in this vector DB, so that it is much more represented and easily attained. So once this process is done, you can ask any queries. The query will be converted to embeddings, and now the semantic understanding of the question to different chunks of information which is in the vector DB will be matched upon, and will retrieve the most relevant piece of chunk and will be present to the LLM. Now the LLM will try to barge up this answer and gives you the right response for the same. This is how a RAG pipeline can be done, which you can use it for any different documents, like starting from a simple PDF document to a complex CSV file. Let's say you have an Excel sheet that has the sales of an entire year of a particular product. You can ask several questions to the LLM, including the RAG, to give you some detailed information of this particular Excel data. So those things can be done with this uh, you know with this rack part. Now let's see this in action before we see the program part for it. Do we have any doubts or clarification on this rack part?
Participants, are you available? If you have any queries, Kindly stop, sir.
No query, ma'am. Very clear, ma'am. Yeah.
Okay.
Okay.
Okay, sir, proceed.
Here, yeah, let's dive into the program right away. So let me just open the same collab notebook. In the second block, I've used the, okay, let me just copy this, you OpenAI key, the API key, because I have to change it. Again, you can also do the same. You can just change this, and also you change this model name as well. Let me just go with this. Okay, uh, OpenAI GPT OSS and change it down here. Okay, that's it. So just two changes as usual. Let's see into the program. So these are the components which you are importing right now. Okay, so you know about chat OpenAI. That's where you load the LLM and retrieval QA, LLM chain, stuff document chain, prompt template. These are based for RAG part. And this PDF plumber loader is basically a library that can load a PDF file and extract content from it. Okay, and then you have semantic chunker. As I told you, like, creating chunks of information is very important. If you don't have the right chunks, the model can't get the right answers, and semantic chunker can do that. Basically, you don't have to do it manually. You can automate this chunking process. And to do the embedding, I'm using Hugging Face embeddings. You can use different set of embeddings for it as well. That's up to you to decide. And then I'm using the FireDB for my vector storage, so that I can store all these informations of my embedding data into this vector format. Okay, that's what I have here. And yes, this is done. So first thing is, like, as usual, I'm going to give the key and the base. And the second thing is I'm going to load this particular data. Okay, what I will do, I'll just yeah, just copy this. This is somewhere safe. I'll just run this part entirely so that, while it runs, I can just show you, like, I'll just teach you like what it happened. So basically, I'm just loading this PDF file, which I've cloned recently. So you can also load any data. You can load any PDF in this Colab also, or even on your local machine. So if you see here inside this deep learning, inside this RAG, uh, you should see this PDF file. Yeah, you can see this, right? So just copy this part, paste it down here. You can start loading the PDF data and load the contents of it. So first thing is, like, I'm just going to load the document and show you the length of the doc. So, like, basically how many pages are there. So once the data is loaded completely, I'm going to use a semantic chunker to do this text splitting. So what I'm going to do is I'm going to equip the semantic chunking with the Hugging Face embedding, so that see, basically, to find the semanticness of the data, you need to have the embeddings. So based on of the embeddings, you see the relevancy of the data, and then you chunk it. So which means that I'm going to use Hugging Face embeddings way before, before my chunking process, because, to chunk it, I want to find the semantic connection of all the sentences and the documents. Based on that semantic connections, I'm just going to, like, chunk it. So the text splitter is going to give onto the documents together, and that will create documents. So these are like individual chunks. The documents represents individual chunks. So once the chunking is done, I'm just push all the chunks to the embedder and convert everything into embedding values, embedding vectors, and store it in the files vector DB. Okay. So what I do, first I load the data and then push it into a semantic checker and split the data into multiple chunks, and then push it to the Hugging Face embedder, convert all these chunk into embeddings and store it in the Fires vector DB. And also make sure you create a retriever function so that you ask a query, it goes into the vector DB and look for similar data, similar looking vector values, vector chunks, and retrieve top two results. That's what we have done in the vector DB part. So vector DB is responsible for storing the data and also for retrieving the content. Okay. And once that is done, as usual, we're going to use the LLM function, chat OpenAI function, to load the LLM and keep it ready. And this is where the important section happens. This is where the RAG part basically works. So now we have set up the environment for RAG. We have loaded, we have chunked it, we have stored everything in a vector DB, then it's job done. And what I'm going to do is I'm going to give some information, like, you are a doctor, maybe. I can just, this system prompt is very important. Okay, you are a experienced doctor. Use the following piece of context to answer the question at the end. Answer only using the context and be concise. I'm just saying be concise. I'm not just giving any limitations. Also use a proper doctor tone to give a response to the question. Use bullet points and emojis to answer instead of a paragraph. So these are some system prompts which I am trying to give to my LLM so that the LLM will adhere to this section. Okay, the system prompt is already available in your ChatGPT and many other LLM providers. I'll just show you that once we finish this part. So once I do is what I do is I just given the system prompt, retrieve the context and paste it here. Whatever question I've asked, which will be like pasted here, and answer will be left empty so that the LLM will try to generate the completions for it. So what happens here is I just call the command retrieval QA, where I'm going to call this combined document chain and the retriever. Combined document chain is another function where I'm going to call the LLM chain and the document prompt together. Now LLM chain is created over here where it basically loads the LLM and the chain prompt basically. Chain prompt is from the basically the template. So whatever prompt which are given, will be given to this chain prompt. The chain prompt will be loaded in the LLM chain. LLM chain will further called here. And this document prompt is basically gives you even more additional information like which page from it, which source it from this, which source this chunk is created, which page number is this chunk is coming from. All these other information will be like stored down here. And both these things will be given. And finally, you call this QA function and you can retrieve these operations. So once everything is done, I'll just ask some questions. Let's say, what's the natural remedy for cough? Yeah, this is how the question will go inside. You see, right? So you see, right? This is one particular chunk. Okay, from the context basic home station, that's the source which are taken. And what it has done, right? So it is not chunked into multiple section. It has chunked this entire thing because if you see cold, flu, cough, and headache are almost has the same information. So that's why you see like this is chunked into one. Second thing, this other section is chunked. That is basically huh, okay, some place in the data. It's because I've just kept for two things, right? Two retrieval. So this is the second retrieval, which is not as relevant as the first one, but let's see like how the LLM gives you. So the LLM gives me the answer like the natural remedy for cough is honey and lemon mixture combined 1 tablespoon of honey with warm water and a splash of lemon juice. The soothing drink helps calm the throat and reduce coughing. Another option is tulsi tea boiling leaf. So it gives me some some output. So it looks something like this. And if I show you the document for cough, you see ani and tulsi. That's what it is referred. Now, if I ask the same question to this particular part, okay, let to this open router thing, let's see like what it does. I'm just gonna copy this question. See like what it does here. Ask the same question to the normal LLM, which is not having any documents linked together. You see that it is giving me a very huge data. It talks about something like how to use hot honey and warm water, ginger tea, steam inhalation, salt water, humidifier, herbal teas, apple cider vinegar. Likewise, it is giving me a lot of informations, basically, right? Because like basically it is a regular generic LLM, okay? But if at all we take this rack pipeline, you saw the output, right? It is sticking towards the context. So whatever context we have here, it is sticking towards that and it answers me. So that your answers are much, onto the context which you're trying to paste. Now, if at all I ask this particular question, I just copy this entire thing, copy this, and maybe let's just, I'm not sure like whether I can run this entirely, but let's see, like, I hope the tokens will be sufficient to put inside. Let me just paste everything. Okay, I'm just gonna paste the entire thing. Okay, assistance you see, right? So the natural remedy for corpus annual element mixture combine 1 tablespoon. So now we see like it, whatever response you see is almost the same as what we got. The only thing is like how did we arrange this is what important. Okay, because if I can get this arrangement correctly, all the piece of information correctly into one single shot, I can get the output which looks something like this. So whatever output which I got here will look something similar. Natural remedy for corpus annual element mixture. If I go up and I see, it's also the same, right? So that's what. So it's all about presenting the data to the LLM, and that's where your open router shines a lot. Open router can give you a wonderful output because of different models, and this RAG helps you to stick to the context of whatever data you have. It will stick to that particular portions. Now that's how things are basically done here. Okay. So this is how the RAG pipeline is created, and you can do a lot of wonders with RAG. And yeah, do we have any other questions or clarifications before I show you like how to do this, local system? Yeah, the same program which I'm doing right now. Right, so I'll just run this. Yeah, I'm just gonna load the local host, and then yeah, so you see, right? So the same thing which is given here, but yeah, I'm just using a simple model. That's a Quen model. Let me just retrieve it. It might take some time to load and run because it's my local system. It has to do this text splitting and everything to be done. It might take some time to do that. But yeah, the output which you get should be, should be much more relevant to what we see right now. Okay, so that's the advantage of this local host. I would preferably use local host. Oops, I have to start this. Luckily, it's not entering inside that. Okay, so I might need to load a model as well. Quickly, let me load it before you ask a question. Okay, still it is like doing this embeddings, so we have sufficient time to do that. Yeah, the Quen model is loaded, and we are very much good to go. Even though if I don't load it right, it will load it automatically. Once I all I have to do is just establish the connection and load it. Now, yeah, now you see the chunks are ready. Now it is like pushing it to the vector DB. That's your FIS vector DB. FIS is a very famous vector DB. There are many different vector DBs like Pinecone. There are bit different approaches, but FIS is a much more faster DB. It's open source. It's done by Meta, so that it's much more efficient to do. Yeah. Now you see that the question is created, and answer to the question stops here. It is like trying to fetch information from the LM Studio. You get the output here, right? So you see the output here, and that's what you get it here. So you see any lemon tea and something like that. This is the thinking part. Is in the provided content. Let me look through the content again. In section 2 of home remedies for common elements. So that's what it is reading. So it is understanding and reasoning it out and gives me the answer, something like this. Since it's a thinking model, I can know like how this is working, and it's something like an explainable AI that gives you one more better ideology behind it. Hope this RAG portion is somehow clear to you. Any doubts or clarifications?
Dear participants, if you have any clarifications required, kindly raise your hand.
Good evening, sir.
Yes, ma'am.
Yes, actually, I implemented one model, sir, using this LLM. So
Mhm.
up to the separation of chunks, I have completed. What is the next step I need to proceed for this completion of this RAG model?
Yes, ma'am. So if you see this program, so
Okay.
once you chunk it, all you
Yes.
have to do is just push it into a vector DB.
Yes. Okay. Okay. Okay.
So you push the data into, first you convert all the chunks into embeddings, and you push all those
Yes.
embeddings into vector DB, and then it's job done. But once that is done,
Oh,
we have to create a retrieval function. This QA chain from this particular function has to be called so that the retrieval is done properly and the data are aligned in a much more aligned fashion. Let's say you have the context, you push the context here, you push the question here, and you push this entire
Okay.
set of prompt to the LLM.
Okay. Okay. Okay, sir.
That's how it's done.
So
Yes.
can you say me some free OpenAI key platforms which we can take free keys?
That's what this open router provides you free models. We don't have free keys for OpenAI, so we have to buy that. But you can
Okay.
use this open router,
And for
server.
practicing these concepts, we can use some free keys, right?
Yes, ma'am, you can see, right? So as I told you, open router gives you
Okay.
free keys. This OpenAI
Okay.
model, this is for free. Whatever free is shown here, you can use these models.
Yes.
Or you just copy
Okay.
create the key and then just use it. That's it, ma'am.
For particular organization, if we are going to implement this LMMs, we want to purchase a key, right?
Yeah, it's better to load it in our local machine as well, ma'am. So let's in this case,
Okay.
I
Okay.
loaded this LM Studio and loaded a local model. Now this local model doesn't require any keys because these are open source models. I can just create a server
Okay.
and just push this model and then just communicate with that. Rather than just purchasing key from corporate different content different servers, this would be much more
Okay.
reliable for corporate scenarios because you have everything in your local premises and you can do anything which you want. That's the most efficient approach when you want to like push it as a product inside your corporate scenario.
Okay. Thank you, sir. Thank you so much. It's a very wonderful session, sir. Thank you.
Thanks, ma'am. Thank you. Yeah. Any other questions?
Thank you, ma'am. Any other participants? Do you have any query? Please ask, sir.
Okay. So there are no queries. I'll just simply just show you like even in Chat GPT, right? So you have all these you know uh, facilities available. Okay, let it load. You see this customized GPT, right? If you go to this customized GPT, you can add any set of output. Let's say chatty. Uh, this is the system prompt which we just uh, given in our rack part. So you can add a system prompt like like keep it concise. Some because many time you ask a question, right, it always gives you a very lengthy answer. So what you can do is instead of giving that in the question, you can push it as a system prompt. Keep the keep the answer to always to a concise manner. You can give some information about you. Let's say you're a software engineer and some advanced things like you can tell you about like you are a Python developer, something like that. So you ask a question about Python, it doesn't talk about a movie, it gives you some programs for it. So this kind of particular traits will definitely help you. Let's say what do you do? You do programming. So you give all these informations, uh, you know, uh, all these things can be done, and whatever personality your chat GPT should have. Let's say cheerful and adaptive, critic and sarcastic, efficient, blunt, so thoughtful, nerd and expert. So likewise, you can have different options here. This is the system prompt, okay? Because system prompt is very useful, okay? Without system prompt, you can't tune the model in the right direction. Because in this example, I just say that you should be a doctor. Since I've given in that particular system trait, it gives me an answer that is that makes it looks like a doctor basically. The output which you get it from here, right? So it makes you feel like it is an output or a model, sorry, the response is generated by an actual doctor. That's the advantage of system prompts. Okay, the system prompts are much more, useful in terms of getting the right output done. And again, combined with your rack pipeline, you can do a lot of wonders with it. And yes, make use of this open router. And I guess recently this Gemini 2.5 image flash preview is also given out for free. You can ask it to generate images, but you need to do some streaming operation so that you can showcase that output as a stream, because you'll get it as a byte values that changes alone have to be done so that you can use it to generate images also. If you click onto this, you can get a lot of information about this model, like what's the throughput, latency, what is the activity, what is the uptime for it. This is the API key for it. So you see, right? So uh, you just upload an image. Yeah, they're just given you some sample example, HTTP referrer, X title, your site name or something like that. And then you just give a text, like user type, and then job done. So likewise, you can, just see like how you do it, how you see it. And you can also, the most important thing is you can even chat it inside open router, see like how it's, how it is creating. So you can just creating an image, I can ask you to create it. So you can do a lot of stuffs, with that. The most important thing, like the strawberry test, strawberry test is a very, neat thing, like how many are in strawberry. Many model will struggle to get the answers right. If at all, if you ask this this small LLM, that's your Quen B, as the same question, this will struggle a bit usually. The Quen model will struggle a bit because it's a small model. Because whenever you have a small model, the capability will be very limited. You see that it is saying it is only having 2 hours, but basically Strawberry has 3 hours, and which the bigger model is finding it very easily. But the small models will have this particular problem.
1 second, sir. I will mute everybody.
Yeah, that's
Yeah.
yes. So basically, like, a small model have this tendency of making mistakes. But the advantage is you can load it in your local machine. You can get things done in a much more proper way. That's the advantage of small models. And that's why we stick with this RAG pipelines. And sometimes even RAG pipelines is not doing a good job. That's where we go with fine tuning. If you do fine tuning, you will be even more getting better results. And that's one important thing to be kept in mind. And you not to know like which model works good for which problems, just go to this website called LM Arena. Okay, so this LM Arena gives you a wonderful information. They kind of maintain all these leaderboards. If you see here, if I click on the leaderboard, it shows you like which model is really good in terms of text, terms of web development. You see that GPT-5 came really recently, but still Gemini 2.5 Pro is doing a very good job. Web development, GPT-5 is doing a very good job. But Claude, usually like for web development, for vision task, always Gemini is really good. Vision, text to image, all these things, Gemini is really good. For search engine, O3 is doing a good job. Gemini is not doing a good job. Text to video, image to video, Copilot. You see, for Copilot, Claude is the best model, and then you can never see GPT-5 in this. But the beauty is like, you can see like all the latest model which is there for different categories. This will help you to find like which family to go with. Let's say I talk about Quen, right? Quen 3 model is what we are loaded. So you can see like Quen model is it's at a decent place. It's at the 8th place apart accordingly. Like if you see like all these models, I just click this enlarge view. You can see like all these models are proprietary. You can't use Gemini, GPT, Claude, everything is payable. But if you see this Quen model, right, it's a freeware. It's an Apache, 2.0 license, which means that you can use it for free for any productization. That's the advantage, and mostly proprietary models comes with a cost. You have to purchase an API key to, basically get things done. But you can search for this, look for better models, look for free source models. Let's say wherever you have this MIT or other license, you can download this for free using LM Studio, and you can do it. But basically, you have to make sure you have a powerful system with you, or you should have a powerful, model or a server to deal with. Okay, if at all, in that case, you can load these models and get things done in a much more proper way. Just the most important thing is like if you go to a new chat, you can have a side-by-side battle. You can, uh, you know compare Gemini of GPT-5i and Gemini 2.5 Pro together, count how many are present in strawberry.
One doubt, madam.
Yes, sir.
Is Gemini is better than Chat GPT, madam? Is Gemini?
Uh, yes, basically the thing is like, Chat GPT uh, has a lot of users,
Yeah,
and
yeah.
it basically has this concept called RLHF, reinforcement with human feedback. So basically, based
Yeah,
on a lot of responses, they kind of sugarcoat the output in a much more better way, which is consumer bias. But when you take Gemini in terms of raw performance, it's doing a
yeah.
very good job. That's why if you see in the leaderboard, almost
Yeah, yeah.
like in all the places, Gemini is top charting. But in some places, GPT is also top charting. But that's what
Yeah,
this
yeah, yeah.
particular LMINA will give you a good idea. So like, see like which model does what type of job to what type of
Yeah, yeah.
what type of
Thanks, madam.
modalities. Yes, sir.
Right, yeah. Yes, thanks a lot. Yeah.
So, and we all know that text to video, VO is doing a very good job, right? So all these
Yep.
wonderful videos which are getting, it is evident that's we can see it here.
Yes.
So this is a wonderful website. You can use this, and basically like you can use this to find the small models also, like at least the family of it. So that you can use that for particular task. Let's say for web development, I'll just construct Quen because Quen coder. I'll just download the Quen coders of the smallest size and then use it because these are like closed source, like these are proprietary models. I can just simply use this guy. And if I take this GLM, I guess GLM is also an MIT. I guess you can use this GLM. We did saw this freeware version and GLM also available here. Yeah, GLM I did saw freeware for it. Okay. Okay, never mind. So yeah, GLM is also there. You can use GLM, model. I guess it's from it's a vision language foundation model. It has 106 billion parameters. It has a decent size. So you can see like for every model, you have a token size. For this one input token, you have to spend $0.5. And for small models, it's like lesser than that. So this, you can also purchase, tokens from open router and you can use any models. But you could see bigger models has bigger token values. Okay, but this is a very good, useful playground to check with different models outputs. That's what open router is very useful. But again, in order to, before we go that, we can always use this LMiner to get it because we are the ones who's going to like give this, words. For example, I just ask like how 1 + 1 equals 2. Explain. If I ask this, side by side battle happens here. You see GPT-5 and Gemini is both are generating the response. You can see like which is generating a good response and you can vote for it. That's the advantage of this LMI because all these votes are done by human beings, not by bots or anyone. Human beings are doing this voting and they have a strict guidelines on voting process and then they do it. You see like Gemini 2.5 is little faster than GPT-5 high and you can see it started giving me some output. Both are lengthy in nature. Okay, it kind of start with a very small output, let's say using sets, a number, everyday idea. But this guy, he just gave me like a hell lot of explanation, like explanation based on number line, and then a simple real world explanations, and then formal mathematical explanation, given me like all the important information which I require, and also a simple summary. So if I feel like this is useful for my particular prompt, I'll just say write is better. Likewise, I can vote for this, and I can uh, you know uh, contribute to the community so that the leaderboard will be much more better in this case. So if I go to start voting, I can also do an anonymous battle, ask questions and then be done with it. So this would be very useful, place to look for. You can see like arena overview as well, like overall, which is doing a good job for which type of modality. All these things are there. Yeah, so you can use this very effectively for it. Yes, any other doubts or clarifications?
Participants, any doubts you have? Sir, if they don't have any doubts, can we conclude our session today?
Yes, ma'am. Yeah.
Okay. I hope that, yeah, many people have given thank you. It seems that they don't have doubts. Okay, Deepan sir, actually, this session was really useful for the people who are working on with this transformers and how it is working with our LLM models. You have given us a complete idea about how this particular transformers are enabling the machines to understand, generate, and to transform some of the human like text. That's how you started first, and then you talk about the attention mechanism and the large language models with some of the real world applications. Also, you have given us some of the provoking thought about how this LLM model is working and how these various GPT models are working, which was really enriched with much of information regarding this transformative technologies. So I hope that this today's session was very much helpful to our participants and to get to research about any of the real time operations, and basically we can understand that how this reinforcement learning has been utilized in the form of taking input from the end user as prompt engineering and prompts, and then how it is taking the based on the inputs by the human, they are training their models. This is basically basic behind this GPT models. I hope so, because you have given us the difference between how this chat GPT is working, Gemini is working. It was really wonderful. So thank you very much, Deepan sir, for contributing your time and providing us a valuable information. I hope our participants also will accept the same. So in this regard, we can give a applause to our sir, uh, showing our appreciation for the presentation he has made today. Okay, okay, Deepan sir.
Thank you, ma'am.
Um,
Thank you so much.
there is one person who is raising hand. Shall I, Mrilani? Okay, no, no raiser. Okay, so it was very nice, Deepan sir. So I will be leaving this meeting, but kindly give me some 2 minutes. Why? Because I have to stop my recording. Okay. So participants, you can give your message in the form of thank you or something like that to appreciate our presenter. Okay. Thank you, Deepan sir. Thank you very much.
Thank you, ma'am. Thanks for the wonderful opportunity as well. Yeah, thank you.
Yeah. Thank you, sir. Okay, sir.